In previous labs, we looked at spherical joint with 3 rotational degrees of freedom, and we looked at revolution joint with 1 rotational degree of freedom, and we looked at point line with 1 translational degree of freedom and 3 rotational degrees of freedom. In this lab, we want to look at a cylindrical joint. So a cylindrical joint has 1 rotational degree of freedom, where it can rotate around the axis, and 1 translational degree of freedom where it can translate. So we can rotate around this axis and we can translate in a straight line along the axis. If we go too fast, again, the calculations can't keep up with the motion, so we need to be careful that we don't go too fast when dragging with the mouse. It's best if we control only with using the simulation player. So if I go into the cylindrical joint and I go to the properties, so we see 1 translational degree of freedom and 1 rotational degree of freedom. If I click on that rotational, we see an arc here, so it can rotate around this axis, the z-axis. And when we create an assembly, a dynamic simulation, it creates a local coordinate system. So this coordinate system might not match this global world coordinate system. So let's look at how to set this up. Let's start a new part file, and this time let's select metric units. So I'll go to the metric folder and I'll select the standard millimeter IPT, and then I will start a new sketch on the XY plane, and I'm going to draw a vertical line from the origin. I will then draw a circle at the end of that line, and I want to dimension this as a radius dimension. So I'll do dimension, I'll right click, and I'll say dimension type radius, and I'll put in a radius of 6.25 millimeters. I will then draw a horizontal line below the origin, and I'm going to dimension the length of this line as 75. I'll do coincident and put the midpoint of this line at the origin, and I will change these 2 lines to construction. I will then draw a line over top of this construction line from about right here over to about right here, and then I'll click and drag an arc off the end of that line up to this circle, and do the same thing on the other side. So I'll draw a line from here over to about here. I'll click and drag an arc, and I want to make sure it's going the right way up to this circle. Now it may not have put tangents on here automatically, so I'll do tangent between here and here, tangent between here and here. I'll make these 2 arcs equal. Do this arc is equal to this arc, and I will then dimension either this arc or this arc as radius 5. And I'm going to drag this arc down to about like that, and I'm going to make this horizontal constraint with that one. So I'll do horizontal, this line, this point with this point. It all turns dark. I'll do trim. I'm going to trim away the arc below here, here, and here. Alright, so now it's all fully defined. Now I intended to make this as a sheet metal part, and I forgot to start from the sheet metal template. So I'm going to go to the environments tab, and I'll tell it to convert this part from a standard part to a sheet metal part. Then I'll go to the sheet metal defaults, and I want to change the thickness, the default thickness, to 1.5 millimeters. 0.5 millimeters for the thickness. Then I'm going to do a contour flange, and I want this flange to be above the sketch, so I'm going to flip this to put it above the sketch, and then I want it to be mid-plane from the sketch, a distance of 100 millimeters. I'll save this file, and I'm going to put this in a new folder, Cylindrical Joint, and I'm going to call this Cylindrical Joint Lock Plate. I'll change the color of it to some other color. I'm going to use blue. You could use whatever color you like. Then I'm going to start a new sketch on this face. Now we could do this one of 2 different ways. We could use this unfold and select this face and tell it to add all bends and unfold apart like that, or I'm going to show you an alternate way. So I just undid that. I'm going to start a new sketch on this face, so I'll go to sketch and start a new sketch on this face, and then I'm going to do project flat pattern. So I'll do project flat pattern and then select this face over here. So everything from here on down to here it's going to project that as a flat pattern. Now it might be easiest to see what I'm doing next if I go to wireframe view mode so that I'm only seeing that flat pattern. I'm going to change all of this to construction. So I'll put a window around all of that, right click, change all of that to construction. Notice that I have 3 lines for the bend on this side, and I have 3 lines for the bend on this side, construction lines, and then I have a line going halfway in between those 3 lines on this side and the 3 lines on this side. I'm going to do a center point slot, and I'm going to select the midpoint of this line, and I'll come over here about like this, and I'll come up about like that. I'll then dimension the distance from here to here as 5 millimeters, and I'll dimension the overall width of this slot as 80 millimeters, and so that portion is fully constrained. I'll then do another slot, and this time I'm going to do a center to center slot, and I'm going to select the first point as the center of this arc, and then I'm going to come down to about here, and I'll come out and click about like that. I want to make these two equal, so I'll do equal. This arc is equal to that arc, tangent this arc to that construction line. Alright, let's go back to shaded mode. So I'll do shaded with edges, and so I've created a sketch and it's on this face. I could have done the same thing with unfold refold, but I didn't really need to do that unfold refold. And then on the sheet metal tab, I'll do cut, and I'll select this area and this area, but I don't want it to cut straight up. I want it to follow the bends, so I'll tell it to cut across bends, and we'll say okay to that, and we see that it cuts across these bends so that it comes down here, stays perpendicular to that face. In fact, let's go to flat pattern. So I'll do create flat pattern. And if we check the flat pattern then in wireframe mode, we should only have one edge along the slot. If you have multiple edges, the cut isn't perpendicular to the flat. I'll go back to shade with edges. I'll go back to my folded part. Actually, I realized that I forgot the holes that I wanted to put into this. So I'm going to go to the XZ plane. I'll start a new sketch, and I'm going to do a rectangle at the origin, and I will dimension then the height of this rectangle as 75, and I'll dimension the width of it as 55. And then I want to change the corners of this rectangle to center point. So I'm going to put a window around and select that rectangle, and I'll come up here, click on center point, and that toggles all of these to center points, but I don't want this one. So I'll click on that center point, toggle that back to a regular point. And then I'll go to the hole command, and I can use either cut or hole on this one. Let's do hole, and it will find those 4 points, and I'm going to do this size as 7.5 millimeters. So we'll do a hole, and I'll tell it to go through all. The diameter 7.5, and you may need to flip the direction depending on where you put your sketch. Previewing okay on mine, so I'll say okay to that to cut those holes, and so then we can go on to the next part. So I'll start a new metric part file, make sure it's on standard millimeter IPT. I'm then going to create a new sketch on the XY plane, and I'm going to draw a 2-point rectangle from the origin coming over to the right about like that. I will then change this line to a center line, and remember the origin was here, so I'll turn on the visibility of that. I accidentally change this to construction. I need that to be a center line, not construction. And I will dimension the length of this rectangle as 100, and I'll do the diameter dimension from here to here as 12. I will then draw another 2-point rectangle from about here, and I'm going to draw that up to about here. I'll change this line to center line, and I will dimension the diametral dimension from here to here as 4, and I'll dimension the height of this as 20. I'll then dimension the location from this point or this point. Make sure you select the point, not the line, from this point over to the origin, and I'll do that distance as 25. And then I'm going to draw a circle from here up to here, and I'll trim off part of this circle. So I'm going to trim off this piece, and this piece. I'll dimension that as 4. Now I'm intentionally going to make a mistake on this because it's a mistake that I see people do frequently, and I want to show an easy way to recover from the mistake. So I'll do finish sketch, and I will do revolve, and I'm going to select this rectangle, and then I'll select this axis, and let's go ahead and save the part, and I'm going to call this cylindrical latch. I'll make that sketch visible again. I'll turn on the visibility, and I'm going to then revolve this area in here about this axis, and then I'll do one more revolve. I'll revolve this area about the axis again. So I see I have a little knob here that I didn't intend to have. Now I could change the sketch so that isn't created at all, or I could do delete face, and I could tell to delete this face and delete this face. But here's where people make a mistake, is we need to heal the remaining faces. So I'm going to check here to heal the remaining faces, but let's not heal that for a minute and let's see what happens. So right now it says solid bodies 1. If I say OK to this, it removes those two faces, but now I have a hollow part, and notice it says surface bodies. It's converted my solid body into a surface body, and so I'm going to edit that feature and make sure you have this heal check, and that way it caps that surface off and we still have a solid body. I'm then going to do fillet, and I'm going to select this edge, and I'm going to highlight that number and make it this diameter divided by 2. So if I change this diameter, this fillet radius will also change. And I think that's all I wanted, so I'll turn off the visibility of the sketch. I will change the color of the part. I'm going to make mine yellow. You can make yours whatever color you want. And then I'll start a new metric assembly. So I'll go into metric, and I'm going to do a standard millimeter IAM. I'll then place, and I'm going to go to my cylindrical joint folder. I'll select the lock plate. I'll right click, place grounded at origin, and then I'll do place, and I'll select the latch, and I'll click someplace on the screen. I will then constrain the axis of this latch to the axis of this hole. And again, it's best if we use the origin geometry rather than the part geometry, except that I think I put the origin down here. So in this case, we'll have to use the part geometry for each one of those. So I might have thought about that in advance, but since I didn't, I'll use the x-axis of this part. And so if I go to this one, I see I did this one with the z-axis, but it's down here. I need it up here. So for my second component, I'll select the side of that. It puts it up there. Now I may need to flip the direction depending on which way it comes in on yours. So I want it to be in this direction. So if I drag this now, it goes back and forth, but right now it goes right through this second part. We could do contact set on there, but I'm just going to locate it by eye. Notice that we have a little bit of clearance between here and here, a little bit of clearance between there and there. So you need to make sure you have that clearance. I'll go to dynamic simulation. It converts that constraint automatically to a cylindrical joint, and then if we drag this, we see right now it goes right through the part. I'm going to undo back to get where it was centered, and then I will do the 3D contact, and I'll select this part, and I'll select this part, and I'll say OK to that. Now when I drag it, it'll go back and forth just a little bit, but if I get it down here, it will come down into that slot and then back. You may want to increase those calculations just a little bit, because you notice it's actually coming inside of it's actually interfering slightly here. So I'll line this up vertically, and then I'm going to increase the calculations, let's say to 500, and I'll drag this now, and so if I go too fast, give me an error, so it can't keep up the calculations. So that is a cylindrical joint with 2 degrees of freedom. Degree of freedom 1 is rotational, degree of freedom 2 is translational.